Good morning, everybody. So I love having a nice little intimate group here. So in case any of you guys looked at my picture on the app, I'll tell you that yes, I am actually Greg Massey. I had an attendee yesterday point out to me that that picture must have been taken many years ago. So I was like, thank you for that. So I'm going to talk about automating prior authorization. And the first question you might be asking is, why are we talking about automating prior authorization? Well, you guys are probably all aware that we had some regulatory changes go into effect earlier this year in January and March. And those are focused on the timeliness of these decisions and also the transparency. So affected payers are now required to publish their approval rates and their average decision time. So you can see there's a big focus on expediting, oh, there's a friend back there, expediting this process. So what we wanted to do is look at how can we help with that. So I'm talking about a hybrid approach, so I should probably define what I mean by that. So by hybrid, I'm talking about using probabilistic and deterministic models to take advantage of both the properties. The components I'm going to talk about today as part of this demonstration in this presentation are using a large language model and using a product we call SAS Document Analysis for health records. So who's our persona we're trying to help with this? Well, we're really focused on the payers, specifically the contractors and the medical SMEs that are doing the processing of the medical evidence that's submitted with the request. So our goal is to provide a quality PA assessment, and to do that quickly so that we can help expedite the decision-making process. So when we looked at this, there were 3 steps we thought we could look at automating. One is summarizing the PA guidelines. Second is to process the supporting medical evidence. And then the third is to generate a comparison for the reviewer that they can use as part of their examination. So you're probably all familiar with the general prior authorization process. So we were really focused on this middle component here and how we could help that section. So what I'm going to be demonstrating today, I'm going to show you this basic workflow. Now, this isn't a product that SAS has built. This is just part of how we built this demonstration. But we're focused on these 3 different arms to kind of address those three strategies that I talked about a moment ago. So the first is focused on the eligibility guidelines. The next is focused on the medical records. And then the last is focused on creating that comparison for the reviewer to use. So the question you might be asking is, okay, we've got an LLM that we're using here. Why aren't we using this to do the entire process? We all know that LLMs are really powerful models. Well, to answer that question, we have to focus on what LLMs do well and what they don't do well. So we all know that they're very good at content creation. You've probably heard stories about LLMs writing creative documents. They've probably written some of your emails. So we know that they can do that well, but we're going to focus on the summarization component. So they're good at abstractive summarization. They're also really good at structured thinking. So those are the 2 components we're going to use as part of the demo today. Now, what they're not good at is factual accuracy. Everybody's aware of the concerns over hallucination. And then the other thing that we know they're not good at is consistency. You can basically take the same model, same data, and the same prompt, run it multiple times, and you're going to get variation in your response. So another question is that first point that I mentioned where we want to summarize the guidelines. So why are we doing that? Well, there's a couple of reasons. One is that unless the document content changes, we're only going to do this once. So that's going to be one time that you have to run this through the large language model to get this abstracted summarization. And so you don't have to repeatedly do that every time that you are asking for a comparison. The other thing that it does is that by summarizing the document, you decrease the number of tokens that are sent to the LLM. So you're going to wind up with a more efficient process and consequently sending fewer tokens is going to result in a less expensive process as well. Just to give you an example, the document that we're talking about today that I'll use in this demonstration, we summarized it and decreased the 17 pages down to 3 pages, just to give you an idea of the scale. So the deterministic models that we're using are 2 different types. The first is based on, or built using SAS Visual Text Analytics, or VTA. And we leverage the natural language processing capabilities as well as the LITI contextual rules, or the LITI linguistic rules that are available through VTA. And the second type is a generalized lightweight intelligence model. And these are zero-shot models. And we bring these into the fold because it gives us some flexibility for the user. So the VTA models have predefined targets or entities that they're trying to extract and predefined documents. But if you need something that's not already extracted by the model, then you can use the GlideText model, and it gives you the flexibility to add that target or that page type that you need to find. Both of these models are focused on not just extracting information, but also finding specific documents within the corpus of the medical record. So why do we want to use these deterministic models? Well, we talked about the disadvantages of the LLM. Well, these are the advantages that we bring to bear with the deterministic model. We get structured output. We know it's going to be repeatable. We know that every time we run this with the same corpus of documents, we're going to get the same results. We can explain those results, especially when we're talking about a VTA model. I can tell you exactly why that text string was extracted based on the contextual cues found within the corpus of the document. We know that these are efficient models. We've got very similar models that were built using VTA that are running in a customer environment and have been for several years. And this customer's analyzing more than 10 million document pages a night. And so it's a very efficient model. It's also obviously very scalable. And then it's customizable as well. And by that, I mean we can govern the response of the model based on the context in which the target's found. So an example is we're looking at we're only interested in extracting current data. And by that, I mean if we are targeting a procedure, say an imaging study like an MRI, we don't want to extract mention of an MRI as an appointment that's been scheduled 2 weeks after discharge that's described in a discharge summary. We only want to extract procedures that have actually happened to the patient. So using this type of model gives us the ability to actually dial that sort of thing in and make sure we're only getting the output that we want. So I just thought I'd show you a quick example of how we execute the SDA for Health Records model. This is using a custom step user interface that's built to work in SAS Studio. It's all point and click. There's no code involved here. Excuse me. The first thing you have to do is select your input, and we offer 2 different types of inputs. You can either use a SAS data set, whether it's a SAS7BDAT or an HDAT file, or you can use the output that's provided upstream from this portion of the SDA for Health Records process, and that's an OCR component that we have. I'm not demonstrating that today, but if you're interested, there is a version of that available in the TriZone, and there's a script you can walk through and actually see how the OCR component of SDA works. But there's some advantages to using the SDA output, so I'm going to talk about that in a moment, and that's why I've got that selected as my option here. The next option is what is your input file. You just point towards that. Give it a path to your input file, select what directory you want the output in. Then you look at you choose what type of export file you want. We offer several different types of options. You can pick an Excel type of file, you can get a CSV, you can get SAS data sets, you can get a JSON payload. So those are your multiple different options that you have available. And depending on how you want to use the output, you can select the appropriate one. And then there's some optional settings that you can choose as well. Now, my eyes are not working well today, so I'm going to go back here so I can see my slides. This is the case sensitivity. So your output, you can choose what case that you want. In this case, or this example, I've chosen lowercase. You can decide, do you want to flag any invalid dates that are output? And this might be handy if you've got an upstream OCR process and you're concerned that it might have inadvertently extracted some invalid dates, or maybe you're worried that your data is corrupted. So then you could just choose your parameters for what are the minimum and maximum dates that you're interested in, how you want to format those dates, and then the last couple of things are, do you want to have the output bookmarked? And this is the advantage of using the output from the upstream SDA OCR process. If we have that as an input, then we can rebuild a PDF of the medical record, and we augment that with some enhancements, and I'll show you those in a moment. And then the final thing is to choose your logging output. The output from this results in several different structured data sets. So these are focused on the page level, the document level, so you can see document summary, page classification, and then the meat and potatoes of the output is the extracted key value pairs that you get from the information. And we do generate some metadata associated with this, and I'll show you this in a moment. The metadata focuses on these keys that are the targets, the entities that we're trying to extract, and then we have some groupers for those keys that are, we call them tags. All right, so here's where it gets fun. We're going to see how this video works. I tried to put some bookmarks in, but I may have to go back and manually stop things. So the beauty of having a, let me stop it here. The beauty of having these data sets is it allows, in SAS, is it allows us to put them into VTA and create a data set, a visualization. So what we've got here is we're focused on 3 of the data sets. If you look at the tabs in the upper left-hand corner, I'll see if so we've got the document, the page summary, and then the key values. So this tab is focused on the document summary, and what that does is it gives you some information about the number of pages, the number of tags that were discovered from the page, and then the types of keys. And so over here you can see the keys that were extracted, the tags that were extracted, and then you can sort your page. Say you only want documents that are focused on laboratory values. So you want documents that contain like a blood glucose. So you could then sort your documents and only look at ones that have glucose values. Now this page summary tab gives you the ability to look at the page level details. And when we're looking at that, we're focused on the classification of the pages here and the page type. So it gives you, is this a progress note, is this a surgical report, et cetera. It still gives you some of the metadata details, but this is really the main factor here that's of interest. And so if you wanted to sort your document or segregate just a particular page type, like a radiology report, you can do that pretty easily in your report. And then the final is our key values table. So this gives you all the different types of targets that we're after listed as the keys. We have the standardized values over here, and you'll see things like down here we've got ACL, and we've translated that to anterior cruciate ligament in the standardized value. The other thing I'll point out is we keep all the raw data in this file. So if you've got multiple mentions like right knee here, we deduplicate that to a single mention of right knee. And we also preserve the positions of the positional offsets of the text strings within the document. So that gives you the actual page where that was found within the document itself. So we'll see if this, nope, it's going to do that. and I apologize. This is just the challenge of working with the video. They wouldn't let us do this live. So let's go back here. Okay, I'll go a little bit before that. So what I wanted to show is that you can select a particular key here. So in this case, or actually, let me back up before that, sorry. So what I want to do here is maybe do a little bit of data quality checking. So I can select the patient values tag when I finally get there, patient details tag, doggone it. I'll come back here. All right, so I can select the patient details tag. And what that allows me to do is do a little bit of, where did I put my pointer? We can do a little bit of data analysis. So what I wanted to point out here is we've got multiple extractions as far as date of birth goes. And you can see all of them are consistent except for this one value here where it's 1974. So this is something you can say, okay, is this a OCR problem? Is this a data problem? And I'll show you how you can actually go back to the document here in a moment and take a look at that to confirm that that is actually an error in the medical record itself. So we'll go forward here. The other thing you can do is look for very specific values by selecting a particular key. So in this case, we know that the BMI is a value that needs to be found in, oh, dadgummit. Let's go back here. We know that the BMI is a value that needs to be found in the, there we go, in the record to assess whether the patient has too high a BMI for a knee arthroplasty, which is the use case we're working with. So you can just double check that really quickly. So just another way that you can explore the data that's been extracted using this visualization. So the other thing you can do is double click on the, so I mentioned you want to go back and take a look at your actual data. The visualization, the dashboard we were just looking at, you can click on the document name and it opens up the PDF that we've generated. And this is why I was talking about there's the value of having that output from the SDA OCR process, because we can actually generate this PDF for you. And we augment this in two different ways. We overlay a searchable text layer on top of the PDF, and we also take the information that's been extracted. Doggone it. I apologize. And we create bookmarks, which I am showing here. All right, I'll just quickly, there's a lot of different details here. You can look at the OCR accuracy if you're interested in that. In this example, it shows the OCR accuracy is around 95%, and that's because we're looking at handwritten document. If you look at one that's printed, you get a much higher accuracy. It's like closer to 100% here. So that's using this printed version. But then you can also take a look at the actual information that's been extracted, and we do hyperlink this to the page from where it's found. But in this case, on this first page, we're looking at condition details that have been reported by the physician. So it's showing knee pain and arthritis, and there it is in the text. So that's where we're getting that from. And then I mentioned that we overlay the searchable text layer. So there's a little drop-down search box in the upper right. I'm searching for BMI. So I mentioned earlier we were looking at the BMI level. I can double check that that is actually accurate based on the data in the actual medical record. All right, you've seen this slide a few times. So this is how we actually deliver the product. We give you two options. You have a VIA-enabled version that obviously works in SAS Studio with the custom step I showed. This gives you the access to all the security, the accelerated performance that you get with SAS VIA. But we also provide a standalone package that doesn't need VIA to be executed. It's essentially a containerized version of the product that you can open and run with Docker. So just trying to give you a little more flexibility there. So we'll get into the demonstration of using the LLM. And I should mention, so we're going to use, well, I'll get into it in a moment. Let's talk about the data that we're using. So this is the protocol that we're focused on. The request is for a right knee arthroplasty. I mentioned that earlier. You've already seen portions of the medical record. This is a synthetic medical record that we just generated for this example. And I input the data as a markdown file for the PA guidelines. And the reason I do that is I've had a lot more success with LLMs, and I don't know what you guys have experienced, but when I use Markdown, it preserves a lot of the structure, and that seems to benefit the output from the LLM. And then from the SAS output, we're taking the key value pairs data as well as the positional offsets that I showed you earlier. All right, so we're going to be using retrieval augmented generation. You guys are probably all aware of what retrieval augmented generation is. It basically allows us to focus our efforts on the data that we're interested in. So the two examples of data that I just mentioned. But in case anyone's not that familiar, I'm just going to show you a very high-level, simplistic overview of what happens. So we submit our query. It goes to the retrieval model that goes to the data that we've shared for the retrieval augmented generation process. That returns the relevant information from our protocols and our data. And that gets combined with the query and sent to the pre-trained LLM. So this has been trained on, thousands of data points, millions of data points, documents, et cetera. But that pre-trained LLM is what generates our response that's returned to the user. So what I've done here is I just wanted to show you the prompts that I'm going to use, because it's a little bit difficult to see in the video that I'll share. This is just a very simplistic prompt, but this is to generate the summarized document. So this is that first step in the workflow that we talked about earlier. You can see basically all I'm asking it to do is give me a summarized list of the guidelines, or the essential requirements. This is just a quick screenshot to show you how the output is organized. It gives us a nice structured response that summarizes everything nice and neatly. This is a little more complex prompt that I'm using to ask for the comparison. So I've got 4 different sections here in the prompt. The first focuses on asking it to review the patient data. So that's the information I've submitted. Then cross-reference that with the checklist or the summarized output that the LLM's already created. And then create an eligibility decision and summarize the final output in its justification. Under the covers, basically what we're looking at is a semantic similarity assessment. And it's taking the requirements from the summarized document, something like chronic functionality, limiting knee pain, and comparing it to the output from the deterministic model. So in this case, we've got some physician-reported problems like chronic knee pain, significant functional impairment, chronic debilitating pain, and then maybe some symptoms that were reported by the patient that were extracted, like effusion and swelling or stiffness. And those, you can see, are similar to the requirements. So that's kind of a high-level idea of what's going on under the covers. So for this example, I'm using Retrieval Agent Manager, or RAM. You've probably seen this in a couple of different presentations already. I'm not going to go into a lot of the details about how RAM works, because this isn't the focus of this presentation, but you'll get a taste of how it can work with this type of a scenario. All right, so we'll see how this video goes. So this is my prompt. And you'll see the prompt that I showed you earlier. Okay, so we've got the summary showing that it's for a knee replacement arthroplasty. It's showing some of the applications of the guidelines, basically that an adult with chronic knee pain. One of the themes I want to emphasize here is that the patient must have completed some, sorry for my highlighting, some non-surgical management, and there's a time component there that's important, 3 months. We've got some diagnostic criteria. We've got symptoms and functional impairment. We've got procedure-specific indications. And then at the bottom, we've got our summary table that I requested. And there's the duration again of time for the non-surgical management. We've got some diagnostic severity with the grade 4, Kellgren-Lawrence grade 4, functional limitations like interference with activities of daily living. So you can see that this is just a little summary. And so we've got more detailed information at the top. We've had the LLM summarize it into a nice little summary, and then it gives some additional things for the reviewer to consider. So this is my longer prompt, and we'll look at the output here. So this is the review of the patient data. And you can see we're looking at standardized value that was extracted by the deterministic model, the page on which that information was found. And then we've got some notes that the LLM has generated based on the comparison. In this case, we're going to focus on the chronic pain, significant impairment. Here's your radiographic findings, the Kellgren-Lawrence grade, the fact that we've done the imaging study as expected. That's a corticosteroid injection, and I'll pause it there for a moment, that reflects that more conservative therapy that it was looking for. Okay, so this is our cross-reference, and you can see it's given us check marks all the way down the line for the 6 different items that it's focusing on. But what I wanted to point out is we've got a partial evidence here. This is the failure of non-surgical management. So this is the conservative therapy that we talked about. So we see that it catches the fact that a corticosteroid injection was documented, but it doesn't mention, it says no explicit mention of physical therapy. And I'm pointing that out because we're gonna dig into that in a moment. Down here, you'll see that this one is implied because the data talk about knee implants, prosthesis, and surgeries, but it doesn't specifically say total knee arthroplasty. So that's something that the reviewer would want to take another look at. And then down here, we've got our summary of findings, we've got our recommendation, and then there are some, let's see if it'll keep going. Yeah, we've got some final recommendation at the bottom. All right. It's a lot easier when you're doing this live. Okay, so I talked about, oh, why didn't you pause? Pause for me. Okay, pause. I pointed out the issue with, oh, you're not pausing. Pause. Did you pause there? Okay, so I pointed out that it didn't have any mention of physical therapy. Well, I've cheated and I know that there is physical therapy mentioned in the output. So this shows you the beauty of working with an LLM, some of that variance we were talking about. So I can dig in a little further and I want to know, well, is that true? Was there no mention of physical therapy? So I can put in a prompt that says, is there evidence the patient received conservative therapy like NSAIDs, non-steroidal anti-inflammatory drugs, or physical therapy? And sure enough, I get a response back, and you guys are probably not able to read that because I didn't zoom in on it, and I apologize. But it says, yes, the documentation provides clear evidence that the patient received conservative non-surgical therapy prior to surgical considerations. And mentions there are multiple entries, note the use of NSAIDs, physical therapy, and was noted, and what I wanted to point out here is this highlighted or bolded says 3 months of formal physical therapy. So that's why it's nice to have this ability to query the LLM. It's useful, it gives you this nice summary, but then you get this sort of variance that we noted, but you're able to then kind of follow up on that. Let's see if you're going to move forward. The other question I wanted to ask is about activities of daily living. So is there any impact on activities of daily living? Because we noted that was one of the key things I kept highlighting in the requirements. Oh, and it did not stop like I thought it did. So this activities of daily living, it says the patient had difficulty walking through the grocery store, also struggled with caring for her children, and exercising was listed as a challenging activity. So those are all things that we extracted with the deterministic model that it didn't find in the data with that original query or prompt. So you've got options. You could try to modify your prompt and you could tune that, or you could take this approach of doing some follow-up queries with the LLM. So I just want to hit a couple of summary points. Hopefully this has given you some ideas about how you might want to approach this. We've got the hybrid approach that takes advantage of the probabilistic and the deterministic aspects of the models. So we have that information that is reliable, and then we can take advantage of the capabilities of the LLM to do the summarization, and also gives us that interface. We can actually have a bit of a dialogue with the data. It does keep the human in the loop, which is always important because we've still got the reviewer there making the final decision. And then we provide these customizable classification and information extraction tools as part of SAS document analysis. And then we have the by enable version that gives you the option to use the custom steps to run the deterministic models. So that's all I have. Hopefully, like I said, it gives you guys some ideas about how this might be executed. And if you have any questions, I'll be happy to try and answer.
Does anybody have any questions? All right.
Okay. Thank you all for coming this morning.